Hey Todd, just want to take a minute and go over how we're able to take in the Modbus registers from the FIOD 0808 and use those basically the input bits and the output bits in ladder. So I've got an application that I created here, and so the first thing that we do is just create the FIOD node itself. So I've got that created. I don't know what your baud rates are and that kind of stuff, but you'd have to change the baud rate to match whatever you have your application set to. So you've got that. And the next thing that we would do is create the Modbus registers for the inputs. So the input Modbus register is this 400,001, and the output register is 400,065. So those are words that we're taking in. So it's 16 bits. And really, we only need the first 8 bits of each of those registers. So what we're doing then is we want to take these communication registers and basically copy them over into local registers. So in one case, we're taking the input, the Modbus input register, and we're writing that to a local register. And for the output, we're taking the outputs that we want to send to the FIOD, and we're taking a local register and we're writing it to that 400,065. So the way this all works is through local registers. And so where we do that is in the tasks. So in the tasks, we're taking the first task here. We're taking we're doing a copy tag B to tag A. So tag B is our source, and that is the inputs from the FIOD. So we're reading the inputs. We're reading it from Modbus register 400,001, and we're writing that to the local register, which is this one here. So we just created that register. And then for the outputs, we're doing the reverse. So we're taking the, this should be the local registers here. This should be the local outputs, local outputs. So that's how that should be. Local outputs to FIOD. So we're taking that and we're writing it to the actual outputs, which would be, this is 400,065, this register. So then how we break down each individual bits, we're doing that in ladder. So if we take a look at the ladder that I've created, we've got just one block that we're doing. And the first section here is we're taking the local input, which is, this is a word, and all that we need is to get the first low byte of that word. So that's what this instruction does. It takes a word and it gives us the low byte of that word, because we only need 8 bits. So that gives us this FIOD input byte. Then what we do is we take this FIOD input byte and we use this instruction, which is an unpack 8. So it's unpacking the byte and it's putting it into individual coils or registers. These are booleans. So now you can take this register and use it anywhere in ladder. So if you had some logic where you needed to be looking at that input, you could have an insert a coil here, and you could just say this is input. How do I do that? So this is FIOD input 1. So you could say this is FIOD input 0 or input 1 or whatever you needed. So now you can use that in your ladder block. So you can use it here. if you wanted to create another ladder block, you just say new ladder block. And we'll just say it's a ladder diagram. We'll say OK. So we could use that here as well. So we can, if we needed to check that input for some reason, we could do that. Let's see. So we'll double click on here and just do FIOD, input 0, or whichever input we needed. Maybe we need 5. But that's how you would do this. So these are all of your inputs. And then the outputs work kind of in reverse order. So again, these are how we're doing the inputs and how we can use those anywhere in our ladder logic. And then our outputs, what we're doing is we're taking and using where each output, this can be controlled from anywhere in our ladder block. So say we wanted to use this, maybe this, if input 1 comes on from the FIOD, maybe we want to turn on an output on the FIOD. So we could say FIOD output, and then maybe output 6 should come on. So then output 6 would come on if FIOD input 1 came on. So in this is how this gets written. So basically this takes and packs 8 bits and it puts it into a byte, which is the lower order byte. So then what we do, we have this byte and we've got to create a word so that we can write that word off to the Modbus register. So you can see here that we're doing this. We have this instruction, which is to make a word. So we're taking 2 bytes and we're packing it into 1 word. Where the high byte, we're just setting that all to 0, and the low byte, we're setting that equal to the result from this instruction. So then the high byte and the low byte get combined to go into this local outputs. And this local outputs, if you remember, that's in the task, and that's where we're writing it to the Modbus register. So that's done in the tasks here. So that's basically how this should work. I haven't tested this, but logically this should work. So I hope this helps.